Let's study chemistry together with CBSE Chemistry Tips and Tricks.
The following data were obtained during the first order thermal decomposition of SO₂Cl₂ at a constant volume. You can see the chemical equation here. They have given the data and you have to find the rate of reaction when total pressure is 0.65 atm. So what is our task? Our task is to find rate of the reaction. For a normal scenario, what is the equation for the rate of reaction? R is equal to K, concentration of the reactant, as it is first order reaction, so you can write 1 raised to 1. As it is a pressure based question, you can write R is equal to K, partial pressure of the reactant. Here what is the reactant? SO₂Cl₂. Okay, present partial pressure of SO₂Cl₂ raised to 1. Correct. Now here, which are the unknown values? We don't know K. Okay, we don't know the partial pressure of SO₂Cl₂, but we know the total pressure. Correct, right? So from total pressure, you have to find the pressure of SO₂Cl₂. Also, you have to find K. Then only you can find rate. Correct, right? Now there is a very important hint for a pressure based question. If the stoichiometry of the reaction is like A gives B plus C, you can see a single reactant whose coefficient is 1 undergoing decomposition to give two product SO2 and Cl2. Again coefficient is 1. Then the equation of the rate constant is what? 2.303 by T log P0 by 2P0 minus Pt. See, first we are going to find the rate constant. Okay, so this is the equation. Hope you understand the hint. See, if a single reactant undergo decomposition to give two product, where if you check, you can see the stoichiometry of the reactant and product. It is 1. Right? 1 SO₂Cl₂ gives 1 SO2 and 1 Cl2. Correct. Then you can find rate constant by using this equation. Okay. So first we can find K. So is equal to 2.303 by T. What is T? It's 100, right? 100 log. What is initial pressure? See, when time t is equal to 0, pressure is 0.5 by 2 times, again initial pressure minus Pt. When time t is equal to 100, pressure is what? 0.6. On calculating, you will get 2.303 into 10 raised to minus 2 log 0.5 by 2 into 0.5 minus 0.6 means 1 minus 0.6, that is 0.4. Then you will be getting like 2.303 into 10 raised to minus 2 log. See, 0.5 by 0.4 means 5 by 4. 5 by 4 means what? 1.25. Then log 1.25, you have to use logbook. Okay, so it should be like 2.303 into 10 raised to minus 2 into log 1.25 is 0.0969. On calculating, you will get 2.2316 into 10 raised to minus 3. As it is a first order reaction. As it is a first order reaction, unit of K is what? Second inverse. So we finish the first task. We find K. Now we are supposed to find the present partial pressure of SO₂Cl₂. Then we can find the rate. For finding the partial pressure, write the reaction. SO₂Cl₂ gives SO2 plus Cl2, right? When the reaction starts, only reactant is there, right? Only reactant. So the total pressure is completely contributed by SO₂Cl₂, that is reactant. Initially, when the reaction starts, on that moment there is no product at all, so there will be no pressure due to SO2 and Cl2. Hope you understand. When the reaction starts, on that moment the complete pressure will be contributed by SO₂Cl₂ because there is no product at all. When the reaction proceeds, the concentration of the reactant reduces. If the concentration of the reactant reduces, the pressure due to its concentration also decreases. So what happened to SO₂Cl₂? See, their concentration decreases, so their pressure decreases. Assume that there is a reduction of P pressure of SO₂Cl₂ when the reaction proceeds at a particular time. From the stoichiometry of the equation, it is very clear that 1 mole of SO₂Cl₂ undergo decomposition to give 1 mole of SO2 and 1 mole of Cl2. What is the meaning of that? It means if 1 mole of SO2Cl2 undergo decomposition, you will get 1 mole of SO2 and Cl2. Or if X amount of SO2Cl2 disappear during a reaction, X amount of SO2 and X amount of Cl2 will be produced during the reaction. So the concentration of SO2Cl2 is decreasing. So there is a reduction of P pressure when the reaction proceeds. So how much increase of pressure will be there due to SO2 and Cl2? See, according to stoichiometry, it will be what? P and P. Got it? So regarding SO2Cl2, initial pressure is P0. See, the pressure reduced is P. So what is the present pressure? It will be P0 minus P. Correct. Regarding SO2Cl2, there is no initial pressure due to that because there is no SO2Cl2 when the reaction starts. But when the reaction proceeds, SO2Cl2 disappear and SO2 and Cl2 will appear. So pressure is increasing, and how much pressure is increased? P pressure. Correct. Now, what is total pressure? Total pressure means pressure due to SO2Cl2. What is that? P0 minus P. Plus pressure due to SO2, that is P. Plus pressure due to Cl2, that is again P. On adding all these things, what you will get? P0 plus P. Got it? So we can write like Pt is equal to P0 minus P, which means P is equal to Pt minus P0. Correct, right? Okay. Now what we are supposed to find? Present pressure of SO2Cl2. It is very clear that what is that? P0 minus P. Present pressure of SO2Cl2 is P0 minus P. Correct, right? Okay. So what is that? P0 minus P. And what is P? P is Pt minus P0. Clear? So it becomes what? P0 minus Pt plus P0. So what is that? 2P0 minus Pt. All values are there with you, right? What is P0? Check the question, okay? P0 value is given 0.5. Correct. 2 into 0.5 minus Pt value is given. What is that? You have to find the rate of reaction when Pt is 0.65 atm. That's the question, right? So it is 0.65. Correct. Now 2 into 0.5 is 1. 1 minus 0.65 is 0.35. Clear? Understood? So we got present pressure of SO2Cl2. So what was our task? Our task was to find the rate. Correct? That is equal to K present pressure of SO2Cl2 or present partial pressure of SO2Cl2. Now all values we already find, right? What is K? 2.2316 into 10 raised to minus 3 into pressure is what? 0.35 atm. So on calculating, you will get 7.8 into 10 raised to minus 5 atm second inverse. Clear? Hope all of you understand. Easy, right? Very, very, very easy.